Hey guys, this is the Module 3 recording of Excel. We made it to our last Excel. Yay us, and hopefully tomorrow or this weekend we'll be moving on to the final project. So our first scenario, we are talking about theoretical and empirical probability. And we used some dice and did some calculations of the sum of the dice and the product of the dice. So in theoretical probability, the probability can be calculated by finding out the ratio of the number of outcomes that are favorable to the event and the total number of outcomes of the experiment, which is what we did in our charts here. In theoretical probability, we are relying on the nature of the experiment and the event and not the actual conduction of the experiment, which is how we're getting our data. With theoretical probability, you do not actually conduct the experiment. Instead, you use what you know about the situation to determine the probability of an event occurring. You may use your reasoning skills or a formula to arrive at your answer, which we use the formula. The theoretical probability of an event occurring is an expected probability based upon knowledge of the situation. It is the number of favorable outcomes to the number of possible outcomes. So when you gather data from observations during an experiment, you will be calculating an empirical or experimental probability. The empirical or experimental probability of an event is an estimate that an event will occur based upon how often the event occurred after collecting data from an experiment in a large number of trials. This type of probability is based upon direct observations. Each observation is an experiment is called a trial. The area above a class interval and it's of data values falling into that class interval, which is what you see on our graphs over here. Each one of these, as we call them boxes, is the area or the class interval. So we used an experiment of rolling 2 dice, and I just did an example. If you roll the dice 50 times, are recorded, which we actually did that over here. But we did it calculated on the 6th row, the 60th row, the 600th, and the 6,000th row. So here is all of the numbers of the sum of the 2 dice rolled. And so the solution to this would be empirical, which is experimental probability, is the probability observed in the chart above. 8 was rolled 8 times out of 50 rows. So the empirical probability equals 8 out of 50, which equals 16%, which up here we did that with the 18 out of 18. The odds against it was 18 out of 18. The probability was 18 out of 36, which was a half. So that was a 50% chance of rolling each die at a given time. Theoretical probability is based upon what is expected when rolling 2 dice, as seen as the sum table at the right. The theoretical probability rolling an 8 is 5 times out of 36 rolls, so the theoretical probability would equal 5 out of 36, which would be 13.9%. And this chart right here is the example. The experiment rolled more 8s than would be expected theoretically. So theoretically, you would expect to roll an 8 approximately 6.9 times. Which I don't know how you would roll a die 6.9 times. So 6 or 7. It's crazy how math works. Empirical experimental probability approaches theoretical probability when the number of trials is large, which is what we did when we were doing the rolling of the dice to the 6,000 times. So in probability, the law of large numbers, which you sometimes may see it labeled as LLM, is a theorem that describes the result of performing the same experiment a large number of times. According to the law, the average of the results obtained from a large number of trials should be close to the expected value and will tend to become closer as more trials perform. In probability theory, the central limit theorem, which is sometimes noted as CLT, establishes that. In some situations, when independent random variables are added, their probability normalized sums toward a normal distribution, informally is what we know as a bell curve, even if the original variables themselves are not normally distributed. And we made all of our charts over here. So this is the sum of the two dies. 6 rows, 60, 600, 6,000, and they're all very different. See how these are all more closer together? And then way over here, we have our products. This is 6 rows, 60, 600, and 6,000. And the higher number of rows you go, you can see where your distribution curve is starting to create a nice curve shape. The next fun thing that we did was binomial experiments and expected outcomes, which kind of stems from the probability. So a binomial experiment is an experiment that satisfies these four conditions: a fixed number of trials, each trial is independent of the others, there are only two outcomes, and the probability each outcome remains constant from trial to trial. And the two binomial distribution formulas that I used are these right here, which has the classy symbols. And our binomial distribution formula variable indication is B is binomial probability, X is the total number of successes, pass or fail, heads or tail, etc. P is the probability of a success. N is the number of trials, and Q equals 1 minus the probability of a success of an individual trial, is the probability of getting a failure on any one trial. So we were looking at if you took a quiz with 10 questions and you scored an 80%, what would be your probability of scoring an 80%? So you would have to get 8 questions right out of 10, and your probability of success is a 1 out of 4, and your probability of getting a failure on any one trial is a 3 out of 4. So we used both of our formulas here and got the 4%, which is a 4 out of 10,000 chance of you making an 80% overall on the quiz if you didn't study and you just randomly guessed every answer. Second, we were looking at everybody's favorite bypass time. I think everybody's get rich quick scheme of winning $1 million off of the lottery tickets. I don't do lottery tickets. So here we're doing a binomial distribution, very different from a normal distribution. And yet if the sample size is large enough, the shapes will be quite similar. And the requirements for a binomial distribution, the RV of interest is the count of success in N trials. The number of trials or sample size of the number is fixed. Trials are independent with fixed value, which P equals the success on a trial. There are only two possible outcomes in each trial called success and failure. This is where the bi prefix in binomial comes from. So the normal Z distribution is a that arises in many natural processes. Continuous means that between any two data values, we could, at least in theory, find another data value. For example, men's height vary continuously and are the result of so many tiny random influence that overall distribution of men's height in America is very close to normal, which we've done on a previous Excel report. The bell-shaped normal curve has probabilities that are found as the area between any two z-values. So that's the two plots. So when we were looking at the quiz and the friend was trying to pump up her other friend that she could actually pass the test. So the friend's outcome is that she feels that her friend can do good on the test just because she got lucky and guessed 8 out of 10 questions right. But the truth of the probability is that she only had a 4 out of 10,000 chance of at least making 80% on the test. As a normal person, not understanding the probability of the odds of the outcome, I would be ecstatic at the thought of just spending $5 and possibly winning free money at least. So we've seen here that you spend $5 on a ticket, a scratch-off ticket, and you win nothing. So you're negative $5. Well, let's say you bought a $5 ticket and you won $5. Well, you didn't lose or gain any money. You just made your money back. Then if you won a $10 scratch-off, you earned $5. So that was a 1 out of 8 chance. So your probability chance was actually 11.669%, and your fixed income was only 58 cents. And so your highest ticket winning amount was $100,000, and you would be plus 99,990. And then your expected outcome would be negative $1.93, and the seller's expected income is that they make $1.93 for every ticket that they sell. And so if they sold a $5 million ticket, they would gross $900,627,181.59. So I feel like the lottery is in a way still gambling, and yes, some money goes toward education, and that's a good cause, but more money is awarded in prizes unless in some cases the winnings are unclaimed and it returns to the education funding, which Arkansas does do a lot of education funding off of the lottery. This helps the sellers from not being totally rigged. So they are making money as long as the tickets are being sold, and they could care less if you win or not, because like we showed, they make money either way. But this exercise, I can prove mathematically why I wouldn't buy these. The odds are very slim to being in your favor. And I think the highest one would be the 1 out of 8.57. So if you spent $5 and you won $10, that was the highest probability that you had. And next would be you getting lucky of winning a scratch-off ticket. So the odds are very slim to being in your favor. It's just a random chance that you'd get lucky to win, which the thrill thought is what keeps most buying them. So the odds of winning the Arkansas State jackpot, 1 in 575,757, with a jackpot minimum of $25,000, where you have to pay $1 to pick 5 numbers from 1 to 39 and match all 5 winning numbers. So what's the probability of that? Do you feel lucky? And so over here, we just showed some of the spending money. So in Arkansas, for every dollar that is spent, 69 cents goes to prizes for players, 22 cents to the school aid fund, and 9 cents for the lottery's ongoing operations and administrative costs. So out of every dollar spent on lottery products, 97 cents directly benefits the state. I showed Michigan again, 62 cents to prize for players, which is more. 26 cents to the school aid fund, which is a little bit more than ours. 9 cents to commissions for vendors and retailers. They actually pay for commission for vendors and retailers. And 3 cents for the lottery's ongoing operations. And then for New York, 59 cents goes to prizes, 32 cents to the school aid fund, 6 cents to commissions for vendors, and 3 cents for the lottery's ongoing operation. So that's out of every dollar spent. That's where the money goes. Next, we had fun with statistics of the body mass index. And I was really thrilled with this one. So my mean was 27.7, standard deviation of 6.15, confidence interval was 0.154 plus or minus 0.40 for the women. And then for the men, my mean was 29, standard deviation of 4.73, confidence interval 0.1954 plus or minus 0.3846. And so here I have the black is the mean. This purple represents my BMI score. And then I did who is now 4-year-old Elijah, and his was 16, and he's this green. And then a friend, Crow, was exactly 22, and he's blue. So my Z-score with a BMI of 25 was negative 0.439. Crow's was a BMI of 22 with negative 0.927. And Elijah at 16 was a negative 1.92. So body mass index is a way of measuring body fat in ratio of weight to height. To calculate your BMI, you divide your weight by height, and this is used to define normal weight, overweight, and obesity. The interval has an associated confidence level that, loosely speaking, quantifies the level of confidence that the perimeter lies in the interval, which would show from here to here, there's a 24%, and from here to here is a 31%. My Z-score was negative 0.439, which means that I am below the average woman's body mass index, or the mean. Arkansas ranks number 7 with 35% of adults having obesity, with a 95% confidence interval of a plus minus 2.4%. The average tells the sum of the value of data points divided by the amount of numbers collected or observations made. So our standard deviation tells us how tight or spread out that is from the mean. This quantitatively calculates our precision of reproducibility of our data points. It is also the positive square root of the mean of the square deviations from the mean, which are these boxes for each. These are each standard deviation. The square of the standard deviation is called variance. That is used as a measure of the variance of a measurement within a group of objects. A Z-score is a numerical measurement used in statistics of value average of a group of values measured in terms of standard deviations from the mean, which is what I just showed you. Confidence interval is a statistical range with a specified probability that a given parameter lies within the range. How confident you are that your statistical analysis is correct, which was the percentages that I showed you from here to here. And when we talk about confidence interval, you can say with 95% confidence variance, whatever lies within whatever and whatever you use sample mean, then you add or subtract the margin of error to get the actual interview. So that's how you can show that with confidence your data is correctly marked on your charts. Our next scenario we did, which is not my favorite, I've been learning about, and you need credit. It's very important. So we were talking about simple and compound interest, and we used some different formulas. We have one formula that's just for simple interest. Then we have another formula for if your interest is compounded, and you can have annually or different types of compounded interest. And then you can have continuously compound interest, which is sometimes when your interest is compounded annually, and then they come back and they compound it again. And that's what that means. So here we showed a principal initial value of $3,600. Our interest rate was 6%, and it was compounded 4 times per year. So we paid interest 3 times a year on this one. So the first year after our simple interest was compounded, at simple it was 3,816, at quarterly it was 3,820, and at continuous it was 3,822. So at continuously we paid $222.61 in interest. And then this just keeps going by. And so just to give you a quick rundown of the formulas and everything, interest is payment from a borrower or deposit taking financial institution to a lender or depositor of an amount above repayment of the principal sum, which is the amount borrowed. So here we were talking about if we were buying a house, and so our principal amount was $110,400, and our rate on that was 5%. So it's the payment from the borrower, which would be you, or deposit taking financial institution. Say the bank bought it for you and then you were paying the bank back, to a lender or depositor of an amount above repayment sum, that's in lieu the amount borrowed, at a particular rate. It is distinct from a fee which the borrower may pay the lender or some third party. So that's what you're really paying as a third party sometimes. It is also distinct from divided what is paid by a company to its shareholders, which is the owners, from its profit or reverse, but not at a particular rate decided beforehand, rather on a pro rata basis as a share in reward gained by risk taking the entrepreneurs when the revenue earned exceeds the total costs. So this is why it's very, very important to know what you're getting into when you're borrowing money, because interest can get high. For example, a customer would usually pay interest to borrow from a bank, so they pay the bank an amount which is more than the amount they borrowed, or a customer may earn interest on their savings, and so they may withdraw more than they originally deposited. In the case of savings, the customer is the lender and the bank plays the role of the borrower. Interest differs from profit, and that interest is received by a lender, whereas profit is received by the owner of an asset, investment, or enterprise. So interest may be part or the whole of the profit on an investment, but the two concepts are distinct from each other from an accounting perspective. So when you are signing paperwork, always read the fine print. The rate of interest is equal to the interest amount paid or received over a particular period divided by the principal sum borrowed or lent, usually expressed as a percentage. And here we showed our percentages. we graph them here too to show the difference from simple compounded and continuously compounded. So compound interest means that interest is earned on prior interest. So it's interest on top of interest, in addition to the principal. Due to compounding, the total amount of debt grows exponentially, and it's mathematically studied led to the discovery of the number E, which we've gone over. In practice, interest is more often calculated on a daily, monthly, or yearly basis, and its impact is influenced greatly by its compounding rate. The benefit of skipping on eating out and applying the extra money towards your mortgage payments is that the more money that is applied to the initial principal amount, the faster it is paid and the less interest it accrues. So it saves you money in the long run. And that's where we showed this here, an extra $50 monthly versus if you paid an extra $100 monthly. So your initial monthly payment would be $632, but you would pay it off in $312 versus paying $532 and paying it off in 479 months. So you save almost $6,000, give or take there. And then your interest is way less. And then next, we talked about subsidized and unsubsidized student loans. Here, our principal subsidized loans was $12,000. We paid a rate of 3.5. We had 4 years until graduation. Our monthly payment was $118.66, and our total payback was $14,239.56. Well, our unsubsidized loan was $13,680 at the same rate of 3.5, same amount of years of graduation for. Our monthly payment was $135.28, and our total payback was $16,233.10. So I'm going to explain to you what that is exactly. A quick overview of direct subsidized loans is they are loans available to undergraduate students with financial needs. Your school determines the amount you can borrow, and the amount may not exceed your financial needs, so you can only borrow what you need. The U.S. Department of Education pays the interest on a direct subsidized loan while you're in school at least half time, so they pay the interest for you. For the first 6 months after you leave school, that's referred to as a grace period. And during a period of deferment, that's a postponement of loan payments. And then a quick overview of direct unsubsidized loans is that these are loans available to undergraduate and graduate students. There is no requirement to demonstrate financial need, meaning that you can borrow more than just what you need to pay for books and whatever you need for school. Your school determines the amount you can borrow based on your cost of attendance and other financial aid you receive. You are responsible for paying the interest on a direct unsubsidized while you pay back more. If you choose not to pay the interest while you were in school and during the grace period and deferment or forbearance periods, your interest will accrue, which means it'll accumulate and be capitalized, and that is your interest will be added to the principal amount of your loan. So strategy number one, pay more than you have to each month, each quarter, each year. Just occasionally you might send in an extra $100, $200 with each mortgage payment in order to reduce your principal, or you might send in a few $1,000s every few months if you can. And this is just telling you how you can lower your interest. Strategy number two could be into a smaller house. Just make sure you factor in the cost of moving along with the cost of selling and buying a new home. It can still be well worth it, allowing you to have shorter term loan that's paid off much faster and to pay much less interest to leaving more of your valuable dollars for other purposes such as retirement savers. And a smaller home will probably cost you less in utilities, taxes, insurance, repairs, maintenance. And then strategy number three would be refinance into a shorter term loan. You can refinance your current mortgage into one shorter term, typically meaning going from a 30-year loan to a 15-year loan. Generally, you can avoid credit card interest by paying your balance in full every month before the end of the grace period. There's primarily two ways to calculate interest for most consumers. First, we have simple interest. That only calculates interest by multiplying the rate of the principal of a loan, debt, or investment. It never adds the unpaid interest accumulated to the principal to calculate its total returns in regards to investments. The returns to many fixed income vehicles like bonds and divided price appreciation or dividend price appreciation are calculated with simple interest. Calculate interest this way would be great for those with loans, as it would keep total payment down, but bad for those with investments who would like to see big exponential returns. Compound interest, on the other hand, is different. This interest is computed on the accumulated unpaid interest as well as the original principal. Certain investments like savings account, certificates of deposits, and reinvested dividend stocks utilize the benefits of compounding interest. This interest calculate benefits you in the it is greater for investments but horrible when it comes to loans. So for the most part, compound interest is what most of us deal with in our savings, investments, and loans. Having some sort of understanding of the nuisance of compound interest can truly help building long-term wealth. And my favorite from Albert Einstein is compound interest is the eighth wonder of the world. He who understands it earns it. He who doesn't pays it. So hopefully you learned something from this. Next, we did gathering data and samples. We were discussing the number of Americans divided up into the different demographics, politicians, Republicans, independents, Democrats, unknown. And we were showing how each one of these feels about our president, whether they approved, disapproved, or was neither. We showed the Republicans, the independents, the Democrats, others. And we have used a lot of formulas with all of these things. And this number was actually off a website that I found really cool, that it was just legit like a ticking clock. So every time you went to that website, it was a different number. It was just continuous. So here we're talking about different sampling. We have simple random sampling, stratified sampling, and we did these different events to show the differences in those. And our second one was we were talking about the Army military branches, the Army, Navy, Marines, Air Force, and the probabilities of if we had a woman that was neither Air Force, Marine, or Navy, and just the different probabilities of choosing a person randomly. So I'm going to explain to you what all that is. In random sampling, each member of the population has an equal chance of being selected as subject. The entire process of sampling is done in a single step, with each subject selected independently of the other members of the population. There are many methods to proceed with simple random sampling. The most primitive and mechanical would be the lottery method. Each member of the population is assigned a unique number. Each number is placed in a bowl or a hat and mixed thoroughly. The blindfolded researchers then pick number tags from the hats. All the individuals bearing the numbers picked by the researchers are the subjects for the study. Another way would be to let a computer do a random selection from your population. For populations with a small number of members, it is advisable to use the first method, but if the population has many members, a computer-aided random selection is preferred. So the advantages of random sampling is one of the best things about simple random sampling is the ease of assembling the sample. It's also considered as a fair way of selecting a sample from a given population since every member is given equal opportunities of being selected. Another key feature of simple random sampling is it's representative of the population. So theoretically, the only thing that can compromise its representatives is luck. So if the sample is not representative of the population, the random variation is called a sampling error. And that's an unbiased random selection, and a representative sampling is important in drawing conclusions from the results of a study. So stratified sampling is a probability technique wherein the researcher divides the entire population into subgroups or strata. So that's where we divided them up into the Republicans, Independents, Democrats. The most common strata used in stratified samplings are age, gender, socioeconomic status, religion, nationality. Stratified random sampling is used when the researcher wants to highlight a specific subgroup within the population. This technique is useful in such research just because it ensures the presence of the key subgroup within the sample. Researchers also employ stratified random sampling when they want to observe existing relationships between two or more subgroups. With the simple random sampling technique, the researcher is not sure whether the subgroups that he wants to observe or represents equally or proportionally within the sample. So with stratified sampling, the researcher can respectfully sample even the smallest and most inaccessible subgroups in the population. This allows the researcher to sample the rare extremes of the given population. With this technique, you have a higher statistical precision sample compared to the variations when dealing with the entire population. Because this technique has high statistical precision, it also means that it requires a small sample size, which can save a lot of time, money, and effort to the researchers. The subjects are selected subjects, for the study, and the researchers did not consider selecting subjects that are representative of the entire population. So, in all forms of research, it would be ideal to test the entire population, but in most cases, the population is just too large that's impossible to include every individual. So that's why most researchers rely on sampling techniques like convenient sampling. It's fast, inexpensive, easy, and so convenient sampling is using student volunteers as subject for the research. Another example is using subjects that are selected from a clinic, a class, or an institution that's easily accessible. A more concrete example is choosing class or choosing the first 5 names from a list of patients. In these examples, the researchers inadvertently exclude a great proportion of the population. A convenient sample is either a collection of subjects that are accessible or a self-selection of individuals willing to participate, which is exemplified by your volunteers, typically would use for feedback or opinion on a survey. Conditional probability is the probability of one event occurring with some relationship to one or more other events. It's used in many areas, including finance, insurance, and politics. For example, the re-election of a president depends on the voting preference of voters and perhaps the success of television advertising. Even the probability of opponent making gaffes during debates. Researchers may also employ stratified random sampling when they want to observe existing relationships between two or more subgroups that makes these relative to each other. You wouldn't want to use given data. Let's just say the different minorities here in Hot Springs. We couldn't use this data to project the number of different minorities in Little Rock because the population is different than ours, much bigger actually, and we would be using false data, and that would be misleading information, especially if we were researching to locate from somewhere else and was looking for a specific religion to join or to be able to connect with other people of the same minority who shares the same values, beliefs, and whatever else you may want to be a part or connected to. So this is why relying on realistic and truthful data is very important. And this was very important to understand when you're watching the presidential elections. So lastly, we got to have fun. Thank y'all for still being with me. So my favorite thing that I did some 3D graphing, and three-dimensional graphing is the act of using a computer program. We plotted solutions of an equation in virtual 3D space so the results can be visually analyzed. Some functions in the equations are plotted in 3D simply to create elegant, interesting 3D patterns or shapes procedurally, while others are representative of data gathered from a source, such as meteorologist information. They use 3D graphing. Many computer applications are capable of 3D graphing, with some allowing the user to customize every aspect of view or create readable plots or colorful images. My first one I plotted was a 3D heart. And then secondly, down here, I called it a half pyramid. Third one I did, which was actually Benzi's example, but I just considered that stepping block. And then I was trying to be creative up here and create a flower. And so here's my flower, which if you look at it from this way, it looks like a flower, but if I rotated it, it looks very different. And if I flip it over, you see the top piece is hollowed, and the bottom piece, which I was considering the stem, actually looks very taller. So you can see that from the first angle, it looked like a flower, but from a different angle, it looks totally different. And that kind of goes in lieu with, our perspective that we take on things. It may seem one way, but if you look at it from a different angle, it may look totally different. See how every time you rotate it, it looks totally different. Oh, that's the wrong thing. Well, this concludes my Module 3 Excel report. Thank you guys for staying with me. And until next time.